Hi, David Bizard here, and you are watching PowerTech 10. What you'll be watching here is episode 17, part 3 of our bearing clearance series. So if you haven't seen part 1 and 2, now's the time to go and look for it. Before we get into the video proper, let me just say it's time for me to say a few thank yous. These are people that without them I would not have made it this far. And I want to thank Tom at DSS. Now DSS is a very successful Ford engine speed and engine building shop. Right? They have some incredibly good equipment, and if I'm in a rush, and this is not an ad, this is actual fact. If I'm in a rush to get an article done, I've done this a couple of times, rather than get a local shop to bore the block I've got, I just call up DSS and they send me a finished block other than the paint job on it. It's got undercoat on. Now, when they machine a block, it is all over, including screw-in plugs and things like this where there's normally freeze plugs. Now, I did an article many years ago on a block of theirs and checked all the tolerances out. It'd be a good idea if I redid that, but anyway, I can tell you that this thing was very accurate, right? So if you are in the business of building a small block Ford engine, or in fact several other engines as well, DSS is a good place to get your block and crank rods and pistons. Here's a video on our channel that you just have to see. This is all about how to slow down your opposition, and it shows the kind of things that age and trickery can overcome when you're dealing with youth and skill. So we go through pretty much the same procedure with all the mains caps that we've done with the number 1 and number 5. I have all the caps off except the one I'm checking. I will check number 2, take that cap off, check number 3, take that cap off, check number 4, take that cap off. Which is about what I'm doing now. So we'll just see what this one is. As it happens, our clearances came out pretty good. Back one was 3.1. This was the tightest one. It was about 2.4 thousandths. I wanted 2.5, so I just wiped over the bearing shell to make sure that everything was clean, and it'd have to go for that. This one here was about 2.6, and this one here was about 2.6 as well. Right, so we're looking good. Everything is within tolerance, except this one was about 1/10 tight. Well, I'm going to leave that and see if I can address that later on during the assembly. Well, that's all the bearing clearance is done on the mains. It's all assembled, torqued down, and lubed with pre-build lube, right? Another word for it is trial build lube. So let's see how easy it turns over. How about that for low friction? Now I'd like to say this is all due to my efforts building it, but to be honest, it wouldn't turn over like this if it wasn't for the precision machining done up at Terry Walters' machine shop in Roanoke. Terry is an ex-pro stock guy. You go in there and you want a high performance engine, he goes to a lot of trouble to make sure you get pro stock standards when it's done for a performance engine like this. Thanks, Terry. Well, so much for the main bearings. It's time to do the rod bearings now. I know someone's going to ask, why didn't I do the rod bearings first? Especially after they see it involves taking the crank back out. It's quite simple. I did this video over a period of about 4 or 5 days. The rod bearings weren't in. but the main bearings were. So I did it that way. So now you know. Ordinarily I would do the rods first, then the mains. So here we go on the rods. When I'm building engines in my shop here and with my students, one of the things that we always do is to check the big end bore size here. Right, we don't do that just with scat rods, we do that with any rods, be they Corello, Crower, whatever. Right, and occasionally you'll find, or we find, that some are slightly out of tolerance, so we rectify that. These scat rods are all in tolerance, and what I want to do now is raise a couple of points concerning these rods. First off, the cap and the beam are numbered. So those numbers go together so you know that the cap is on the right way round. Right? Another telltale sign is the chamfer here. This big chamfer goes towards the cheek of the crank, right? And the small chamfer goes towards the cheek of the rod. And lastly, it's got two bearing cutouts here. They are both on the same side. Right, so now let's take a look at what we did with these rods to prep them for doing our bearing clearances. Our next move is to separate the cap of the rod from the main shank of it here. Now, a little bit on these rods first. I've covered these scat rods in pretty much detail in previous videos, but just to recap on that, these are not expensive rods. They're kind of the Scat's middle of the road rod. They're almost indestructible. I've used 800 horsepower on them, never failed a rod. We've had nitrous motors making 1300 horsepower. Right, the block broke, but the rods didn't. They bent, but they didn't break. Now, okay, back to business here. Now, when you get these rods, the caps are torqued down to about 65 so they can hone this to size. So, you are going to need a fairly big wrench to get them undone. Also, I've been promising myself a rod vise for 40 years and I've just never got one. What I do is I tape up the jaws of the vise with something like Gorilla Tape, 2 layers of it, and I can fit the rod in there for the purposes of undoing it. So that's what I'll do now. Now for the hard part. Right, I say hard part there. Bit of talking. Got it. Yeah, got it. Right. Right, so that's unbolted the rod. Now, since it's got 2 dowels locating the 2 halves, which are pretty much a press fit to make sure they locate in the same place every time, we need to use a mallet to separate the two. Here's how we do it. Put the rod in the vise, holding on to just the cap. Take a hold of this. Done. What we're doing at this point is just taking the sharp edge off here. When you split these rods, you'll find that there's just a little burr all the way around left from the machining. Now, the chamfering we do here has to be very minimal, right? Because the press fit will squeeze out into that groove. Now, I don't know at what point this does, but I've been told by people who design bearings that this is what happens. Now, I can't imagine that a 5,000th chamfer is going to do anything there. Now, when we come to the corners here, always go down like this with a round file. right, away from the machined edge, and then just shave off these edges here, and we're done. Do that on the cap and on the main part of the rod beam. After we've deburred our rods, the next job is to clean the bearings. As with the mains, this has to be a meticulous job. Let me show you what I mean in terms of cleaning them. As with the mains, I'm using cleavite bearings here. And these have what appears to be a finish coating on. Now, it's important that you don't remove that, whatever that top layer is, but it is important that you get the bearing clean. Now, if you look very carefully, you will see that I have cleaned the bearing on the left to the point where it actually is shiny. You'll know when you've got to enough cleaning because the bearing will feel as smooth as ice. What do I use to clean it? As usual, a paper towel, a lot of vigorous rubbing on the bearing, and lacquer thinner. Before we wind up on the subject of bearing shells, last couple of points. Stone off the numbers, or at least stone over that to see if they're raised at all. Just in case I forget, after you've stoned the bearings, grit can get into these here. A good way to make sure you've got it all is a powerful cleaner, degreaser. Harbor Freight has one in gallon cans, but there's others out there that'll do it. And a paintbrush that's had the bristles cut right down to only about that much. So stone those off, and then the last thing is just break the sharp edge there with a chamfer, which is about 5/1000ths. Now I'm going to tell you something about bearings here, and I've measured the thickness of these bearings, right? First off, there's an upper and a lower, right? With the cleavite bearings, the lower bearing is usually thinner. That means it has a couple of tenths more clearance if we assume a perfect circle. Secondly, all high performance bearings, and probably all bearings by now, the wall of the bearing is thinner at the edges here, and what that does is it allows for the big end bearing to distort. And the irony is, since this has come into being, and I think Smoky Eunuch was the one that brought this into popular use, is that rod journals have got more robust, so it's now not needed as much. But back when Smoky was pioneering high performance in NASCAR stuff, the rods were distorting and scraping the oil off with the sharp edge. Just to make sure that does not happen, I don't know if you can see it, the shine, I've just put a little chamfer on there, right? So the bearings have been chamfered, bumped on the numbers, cleaned, polished, and we are ready to go. Okay, long-winded though it's been, we are now ready to actually check the clearance on the big ends. Follow this procedure and it all goes smoothly. Do it without following this procedure and you could be struggling. First move is to position the crank on the bench with the journal that you're going to work on in this position here. You'll see why in a moment. Next, totally degrease the rod journal. Then place, usually takes a green strip, place your Plastigage on here and hold it in place by pressing on each end with the screwdriver. Right, that will glue it in place, and that's the reason we want it oil free. Put just a drop of that trial lube that I talked about earlier on onto the bearing, and just with your finger wipe it over the bearing. right? You do not want any thickness there, you just want a slippery bearing, right? Why do we want this? Because we do not want the Plastigage to stick to this, especially if we inadvertently move the rods whilst we're checking it. Next, position a rod on the journal, right, making sure the big chamfer is towards this side here. Let it rest on the bench. You'll start to see why we needed it in this position. You'll notice that the Plastigage is in the middle here. Remember, we've got more clearance here and here on these bearings. We check the bearing clearance right in the middle. Next, position this one here, being careful not to touch anything on the rod. Once you have the rods bolted in place, right, and just snug these bolts up, put feeler gauges that are a tight fit in here. That's to stop the assembly doing this when you torque it up, right? So that's what we'll do next, is torque up those bolts. At this point we can torque up the rods like so. It's best to have somebody hanging on to the other end of the crank when you're doing this. It makes life a lot easier. Just go around and untorque all the bearings. A check of the widths here show that we have right on 2/1000 clearance. Right, maybe on the this next one here, just a fraction over, probably 2.1, 2.2. So we're good. Well, that about wraps up our bearing clearances on the Jeep. One thing before we finish. Somebody is going to ask, how accurate is this Plastigage? Well, there's an easy way you can check that for yourself. Just get 2 precision ground plates, 2 feeler gauges the same size, say 2/2000 thickness. Put a piece of the Plastigage, the green stuff, between the 2 feeler gauges, squeeze the plates together. If it doesn't come out reading 2/1000, it's wrong. If you do that test, you'll find that it reads 2/1000 really close. Now, it may not be as accurate when we start getting to the extremes. However, this is the good thing about it. It's accurate enough to always tell you when you've got a problem. If it measures out looking about what you needed, the chances are it is pretty much about what you needed. Do we do our stuff in the shop using Plastigage? No, it's actually faster to do it with gauges like a bore dial indicator and micrometers, and write down all the clearances. But anyway, you'll get to that stage when you're a professional race engine builder. So, if you liked what you saw on this video, then please hit the like and please subscribe. It costs a lot of time and money to do these videos. We need to justify that time and money with our audience. Thank you.